Thank you for attending this PLC Easy demonstration. In this demonstration, you'll be shown the distinguishing features of the PLC Easy solution. Before we continue with the demonstration, we briefly review the benefits of this solution. PLC Easy is a Schneider Unity Pro and Wonderware based solution that will reduce the amount of software in an application by at least 30%. And reduces the complexity by at least 50% compared to conventionally built PLC-SCADA or DCS solutions. It provides any functionality based on the same algorithm. This has as a consequence that every application built with PLC Easy is very consistent in its quality. It provides infinite functional redundancy. It follows the S88 and S106 standards very closely for batch, continuous and routing processes. It has integrated exception handling and hardware diagnostics, allowing the hardware diagnostic signal from any type of device, from any manufacturer, to be fully integrated into the PLC Easy alarm management system. The alarm management system in PLC Easy is AMS based and is fully standardized. This will reduce the amount of SCADA development efforts and later changes when it's operational considerably. It has fully integrated energy monitoring and it's easier than DCS systems such as Siemens PCS7 and Emerson Delta V. PLC Easy reduces complexity in applications by standardizing functionalities that are commonly unique and require unique software in conventionally built PLC, SCADA and DCS applications. And in the following demonstration, you will see the standardization of some of these functionalities, which are alarm managing, group control, sequencing, routing, and cleaning in place. Here we see the graphic of a pasteurizer. This pasteurizer contains a number of devices, also known as control modules. And these are valves, analog inputs, digitals, pumps, etc. In conventional PLC SCADA and DCS solution, it would require scaffolding software such as sequencers, group controllers, cleaning in place software, alarm management to create the pasteurizer functionality. In PLC Easy, the software modules like a valve is linked to a pump by using the 8 parameters, and by linking all these control modules together, they perform the cleaning in place functionality, the sequencing functionality, the group control functionality, the alarm management. In PLC Easy, this reduces the amount of software considerably, and at the same time, the software that is reduced is at the same time the most complex software that requires expertise. In PLC Easy, it's just like Lego bricks. We click the modules together, and by clicking it together, it gives me the functionality that I require. By opening the faceplate, the operator is provided with detailed information of this pasteurizer. This pasteurizer is currently in idle in step 0 of the sequence. It performed 26 run hours and the next cleaning in place session is due in 2 hours. The currently short circuit is selected, meaning that the sequence will go from step 1 to step 7 and skip step 10 in order to end in step 12. The operator is informed every step of the sequence, where is it and what action is performed. The S88 guideline states that a sequencer must be able to be paused, and the operator must be able to go in a semi-automatic way to step through the sequence. We're currently paused in step 11. When this step is started, we will see a start delay. This could be the dosing of a chemical, followed by a siren. The operator is informed what's going on and will never have to question what's happening. Then the operator will be notified that the pump is starting by showing the starting string. We like to put your attention to this step as we're going to change these parameters in runtime dynamically. So we currently see the start delay, followed by the siren, followed by the starting string. When we issue a step back, we're now going to reparameterize this step. We do that by opening the pump faceplate, going to the configuration, and we see here a number of parameters that are available to us, including the start delay. Instead of 7,000 milliseconds, we change this to 8,000. If this would be a dosing of a chemical, it would dose a little bit longer. We have a kilowatt rating. We like to know what energy this is consuming. In this case, this is a 7 kilowatt direct online motor starter. We can also take the energy values from a VFD. We can create a star delta configuration showing that the inrush current is lower, so we can provide this for energy saving purposes and control. We like to change the start string. Instead of starting, we like this to say a more appropriate string. For instance, fill tank 5. We will now change the flow direction of the pump. Currently we see that the flow direction of the pump is pointing towards the right, where it should point upwards. By clicking on the arrow, we now change that flow direction. The significance of this faceplate is that where we normally need expertise, a SCADA expert to change the messaging, a PLC programmer to change batch parameters, start delays, energy values, we can now do from the SCADA itself. We don't need that expertise. The sole purpose of PLC Easy is empowerment, and the process engineer or even the process operator here is empowered to change the process to whatever their requirements are. When we now start step 11, we will see the changed start parameters. So we have a changed startup delay. We have a different string. Here's the start display, followed by the siren. And now instead of pump starting, it will state fill tank 5. We'll now resume the pasteurizer sequence, and we will see that once step 12 is finished, the sequence will be complete. We now see that the pasteurizer consumes 7 kilowatts and 34 kilograms of steam. One of the major problems that an operator experiences is that he or she does not know why a sequence cannot progress. Like the status messages can be changed dynamically, so can the alarm messages. When we create a problem by lowering this heating medium level, we cause a stop of the sequence. We see straight away what the problem is. Control valve 1401 is causing an error because it's tripped, and that stops the pasteurizer. When we click on the button here, it will take us straight to the root cause. In this case, the control valve 1401. The problem is that there is a protection interlock that is caused by level switch 1401 that's turned off. We see this message reoccurring in the pasteurizer faceplate. But instead of starting with protection interlock, it starts with the root cause. The level switch 1401 has turned off, which caused the protection interlock to the S88 pathway, pasteurizer 2 control valve 1401, and the control valve is affected by form of being tripped. If we reset this problem, we can configure this alarm message online. By simply opening a faceplate of the level switch, we now change the off string, which is a default of off, we change it to low. Instead of stating that it's off, it will now state that it's low. When we reinstate the error, we can see the alarm message here coming up. Protection interlock level switch 1401 is low, and we see that here as well. Currently, the pasteurizer is running on the short circuit. During production, this route can be changed to storage and to the long circuit. In this case, we're going to demonstrate a change to the long circuit. And what you will notice is that the fluid can remain traveling through the short circuit until the other route is fully available. The significance of this is that PLC Easy will reduce or even prevent hammer in the pipes. We now trigger the long circuit, and what we will see is that the long circuit is first built up. Once it's built up, we can change over to the long route. If the fluid can travel, the short circuit is closed. Again, this will reduce the amount of hammer in the pipes. We now go back to the short route and we will see the same in the PLC Easy solution. Any hardware diagnostic signal from any type of device, could be a legacy device, could be an Ethernet switch, could be an I/O card, could be a vendor's kit. In short, any device that has an indication that there's a problem can be incorporated into the PLC Easy alarm management system. In this example, we're going to show an I/O card failure, and the operator is notified of all the signals that are connected to this I/O card and are therefore unreliable. We're going to see that the PLC Easy system dynamically builds up all the messages, and we see that happening in the bottom part of this faceplate. When we open the information, we can see that Rec 6210 slot 5 is causing a hardware error which affects the manhole switch, which is a protection interlock to this pasteurizer. It also affects the high level switch. It also affects the low level switch, which is affecting the pasteurizer to pump 1101, which is currently stopped. It affects the low level switch 1401, which is used as a protection interlock to the S88 path, the affected device, and the state of the device. With one view, the operator sees the extent of the problem and the integrity of his system. The operator is very much empowered by this information. Not only does the operator see with one view the extent of the problem, but also what devices are affected, and more importantly, how these devices are affected. This allows the operator to act as a manager, because he or she can decide to continue with production or to stop with the production because he or she can recognize a potentially dangerous situation. Cleaning in place. Cleaning in place is one of the functionalities that cause complexity in conventional PLC and DCS applications. We see that the next cleaning in place procedure is due in 1 hour. For this demonstration purpose, we changed the setting so we instigate a cleaning in place procedure. We will see that the operator is notified that the cleaning in place is due. It starts to blink yellow. The cleaning in place due indication says 0 hours, and the operator is advised to stop the pasteurizing procedure. PLC Easy can also be configured to automatically stop a procedure, but for this example, the operator is in charge. When we issue stop command, we notice that the sequence will go through its stopping phase. To speed this demonstration up, we're going to use the abort. The pasteurizer is now in idle, and the operator is advised to put the pasteurizer into the cleaning in place mode. When we issue the cleaning in place command, we notice that the ready idle will change to cleaning in place ready idle. The operator is also advised to start the cleaning in place. Currently, the PLC Easy software changes from production to cleaning in place. The operator is advised to start the cleaning in place procedure, and just with a regular production sequence, the operator is informed what step is active in the cleaning in place procedure. So the sequence is activating. Once activated, the operator will notice the times for water flush, caustic, and acid. If the operator would stop the cleaning in place procedure when it's not finished, the pasteurizer will remain in the cleaning in place mode until the times for acid, flushing, and caustic have finished. Once the cleaning in place procedure is finished, we'll notice that the pasteurizer will go back to the ready idle state, indicating that it's ready for production. Currently, we're doing the caustic phase, followed by a water phase. And once the water phase is finished, we'll see that the pasteurizer cleaning in place sequence is stopped. So currently the sequence is stopping. And once it's stopped, the operator will be notified that the pasteurizer is ready for production. We see that because it now says ready idle instead of cleaning in place ready idle. And it will say that the next cleaning in place session is due in 19 hours. The pasteurizer that was just demonstrated was replacing a conventionally built PLC application, which you see here. The conventionally built PLC application consisted out of organization blocks, function blocks, functions, and instance memory. The functions are the unique part of the software. And if we open one up, we see code in there that looks like this. So we see some ladder, we see some function block, we see some STL. Currently, we have 47 sheets of these codes that used to provide the pasteurizer functionality in the old PLC. In PLC Easy, the 47 functions were replaced by 5, which we see here. Pasteurizer control, pasteurizer communication and configuration, pasteurizer PIDs, pasteurizer analog and digitals, and a pasteurizer cleaning in place. When we look at the analog and digitals, we see here the analogs, which in total are 16. We see here digitals, and we see about 50% of this sheet is filled. All the function blocks that are shown here are generic, so they're standard. We have the PID loops, which are 6. Again, these are standard blocks. Approximately 15% of the sheet is occupied. We have the communication with the field and the configuration. The configuration is shown left here. Whatever was available on the faceplate can be hard-coded by using a function block here. And then lastly, we have the code for the pasteurizer itself, which we see here. The sheets that were just shown are 100% standard logic. The sheet here is predominantly standard. All these code blocks are standard with the exception of these 3 networks. The 3 networks shown here are for the routing and are AND and OR gates in general basic PLC programming. So when we zoom in on that, ANDs and OR gates. To summarize this demonstration, you've been shown some of the main features of the PLC Easy solution and seen how 47 sheets of code have been reduced to 5 sheets of code in the PLC Easy solution. The 5 sheets of code in the application consisted predominantly of standard logic blocks, reducing the complexity of the code considerably and making PLC Easy very suitable for code generation. PLC Easy is commercially available and comes with manuals and instruction videos. If you would like to have more information about the PLC Easy solution, please contact us at info@plc-easy.com. Thank you very much for attending this demonstration.